Hi guys, welcome to Learn Electronics Repair. I have another one of these old but very powerful amplifiers here. So this one is the Musicson P-802. I have an 804 here that's been here for quite some time. I have some parts for that one. And the guy I believe has at least a couple more of these as well. So this one, there's a problem on one channel. I think some error light comes on. We don't have a protect on these, just high temperature standby peak signal. Okay, so we can power it up. I'll put the current limiter in just to be sure it's not going to do anything nasty, but I'm pretty sure it doesn't. Let's see what we have. He tells me one channel is kaput basically, so hopefully we can get somewhere with this one. I might need some parts, but let's have a look at it and see what we have. So we see the light bulb tucked down here. This is just a 65 watt one. I just want to make sure there's no shorts basically, so I'll switch the switch on. There's a little trip that isn't tripped. Let's just see. Doesn't do anything. No, does nothing at all. Just try to switch it away to make sure it's not upwards. Does nothing. Okay, so maybe it's not one channel kaput on this one, maybe something else. May just be it's not plugged in all the way properly. Let's try again. Light bulb comes on dim and the fan spins, so it's not going to go bang or anything like that. We can switch the current limiter out. Try again. Let's see if we get any lights on the front of this. Okay. So nothing lighting up at all on the front of it. Not drawing very much power. Let's see if there's some fuses inside here. Well, I didn't see anything obvious. I'm sure there's going to be some fuses somewhere. Obviously, there's a trip here. So this is what's inside it. I can see a big, like, we call these buzz bars. That's what they were called back in the day. I don't know if it's still called that. But like high current power rails. So this one goes all the way across. One would assume, or at least I would assume, that is ground, and then we have a plus and a minus. Capacitor's not really holding any charge. Let's switch it on again and see what the voltages we have. So no supply rail, no supply rail. So the supply rails are not there. That's the first thing we can say. I can see there's a bridge rectifier down there. This doesn't look complicated. None of this fancy class G voltage rail switching. Let's see if there are any shorts across the voltage rails. We have the very big capacitors here, so yeah, they're charging up, so that looks fine. Assuming this is the positive, I'm not sure. Go for that one. In fact, that has the red wire on. This is probably the positive. And this has a green wire. That's probably the negative rail. So it'll charge in the opposite direction. Or one would assume it will. Just short that again. Okay, yeah, charging the other way. This would be, I'm guessing, the positive rail. Just short that. Yeah, charging. So there's no shorts on the voltage rails. So why don't we have any voltages? I mean, this is coming out of the bridge rectifier. Well, it must be. Which is down under there. And it's not easy to get to. I think I might be able to just like lift all this out so I can get underneath it. Yeah, so these capacitors are held in with like some rather unusual like clips, kind of like a ratchet type thing. I might be able to show you. Yeah, down there you can see them. They're like a slot and a tongue a tongue and groove, yeah, and you must like push like inwards to clamp the capacitor, but the capacitors are actually attached onto these buzz bars by these large screws. So if I undo the screws and just disconnect the wires, I can get down to the bridge rectifier. I want to see if I get any power getting as far as that. Yeah, so if I undo these screws and I just make a note of which wire goes where, and I can lift these bars off, I can get down there then. I want to get down to the bridge rectifier to see if I have AC coming out of the transformer. So we will number these 1, 2, 3, 4, 9. Let's go hexadecimal. A, B, C, D, A, B, C, D. Then we'll try to get this lot off. Actually, I probably only need to take this one off. I don't think these are in the way of anything. Okay. And these, although I marked them all down, well, they all connect to the same place. So that was a bit unnecessary, really, yeah, because these are all common. Somebody probably spotted that already, by the way. This is, I should have known better than that, because it's a bit like the thing with contact lenses, which I sometimes wear, those daily ones that I'm out socially filming on carnivals and face masks and such, yeah. So you go to the optician and like you collect another pack of 30, and while you're there they write "or" on one of the boxes for right, and then they write L on the other one for left. And one day I said to them, why have you written L on that? Because if this one is R for the right eye, am I going to think, what the hell am I going to do with this other one? Where does it go? Yeah. Or is it like self-explanatory? And they looked at me really strange. That was like a very strange thing to ask. To me, it's extremely logical. I mean, yeah. It's like, where am I going to stick this? If you don't write L on it. Yeah. So anyway, I then did this silly thing myself. Yeah. So all these come off here. I was thinking if I was taking these off as well, actually, to be honest. So let's get these off. Of course, there's always one that doesn't want to come. There we go. Right. So that's loose. Off it comes, and now we can see what's down here. And what can we see? Well, to start off with, a lot of dust. Let's just clean that up. Okay, so we can see the bridge now. So I'm on diode mode. I need to disconnect really one of the AC terminals to be able to actually measure this, test it, because these two will effectively be short, which is the winding of the transformer. At least they should be. I'm not getting any sort of sensible reading at all there. And I can't really see how there's going to be any voltage there. So these two are the winding of the transformer. That should be short. It's reading 3.8 meg. Yeah. That kind of explains why we don't have any voltage getting to the capacitors. Let's go to diode mode. Well, because that doesn't read short, I can actually test the bridge rectifier now. So, black on the AC, so we go to the negative, that's a diode. Other one is a diode, okay. And then black read to the positive output, and then this should read diode. And this should read diode. Okay, and across the bridge rectifier in the polarity it would normally be operating. We should read. What is it? Well, I'm seeing a short between the positive and negative. Okay. But I wasn't seeing a short to ground. At least not before. No. So no short to ground, but a short across the bridge. Interesting. So that's telling me between the positive and negative rail I have a short. I do have a short, okay. And it's also telling me that the secondary of the transformer reads open. That's a bad thing. Not exactly open, but a high resistance. But this might actually not be a fault. So we have coming from the transformer another wire here, and that's connecting to this one. Okay, so I have a connection via that wire to this one. I think what we probably have here is, rather than a center tapped wire, two separate wires, and this will probably go to this one. Yeah, it does, and not to that one. So effectively we have two separate windings. Obviously when these are attached to that big metal bar, then this is the center tap, so they read okay. Question is then, why is it not like drawing a lot of power if we have a short, which we do, from here to here? And that suggests that power isn't getting as far as here, which is coming through a little board back here. So we can see this is where the primary of the transformer goes. There's a few wires going down here actually. Okay, so I suspect the power isn't getting to there. There's obviously power getting into the thing because the fan's running. Okay, so we can say that bridge rectifier is okay, so I may as well stick this thing back on now. The rectifier tests fine, all the secondary winding tests fine. And what I can do then is disconnect the wires from here to the amplifier channels and see if the short is on one or both. Just before I do that though, we know this one connects to this one. So if we go to volts AC, okay, and just power this up, we should see some voltage here. Okay, again about 3 volts AC. That suggests there's a problem with the primary winding on the transformer, or something wrong in here. And the fan, as I say, is just 240 volts. That's just probably connected directly to the mains. So let's have a look around here. Well, there appear to be 2 thick wires going into here, and then there's some coming out, 3 there. So it might be that this is another center tap secondary, like a 15 volt plus or minus maybe, and then this one and this one are the primary. I can see the neutral wire coming here from the mains, and I can see the live wire, yeah, coming here from the mains. And then this goes to the transformer, this goes to the transformer, and there's 2 others. They go to the fan. I can pretty much see they come down here. Okay, so that's what we appear to have. There's some markings on the transformer. If we can see them clearly, it's difficult for me to focus a camera from this distance or view it from further away, but let's have a look. So we have 110 volt. Trying to get some decent amount of light, see if we can read that. Yeah, so it says something like 110. So I think we probably got 210 volt rails, and then probably the other ones like 10, 11 or something. Right. Let's work on the basis that this is going to one of these. I think this is the fan. So this is live coming in. Goes to there. Then I think this is the return from the fan coming back. No, that's also connecting to there. It reads a slight difference, but not much. Okay. That was like about an ohm or something. Less than an ohm. Okay. Those two wires are these. So these go this way, and they go very much in the direction of the fan. I can see them down here, so I'm pretty sure that is the fan. Could try disconnecting one in a minute. Then we have this one. So this goes into the transformer here. Okay. And then we have the other thick one, which is here. And this is neutral. So this must be the transformer winding. We have a connection from live coming in. Do we? No, we don't. No, we don't have a connection from live coming in. Let's go from neutral here. You have a connection there, so that's connecting to neutral. But this one doesn't connect here. Okay, looks like a relay here and some resistors, possibly fusible resistors. Another relay. And this one I think is another transformer winding. That reads about low, very low. Reads very low. So the problem seems to be that the live coming in here doesn't connect to there. So probably not the transformer winding. If we measure across the transformer winding, here to here, yeah, it reads short near enough. Okay. Well, say short, an ohm or so. So it looks like we have a problem on this board. And a problem with a short circuit on the output, of course. Okay, I've disconnected all the wires. Some of them were marked with numbers, some were not, so I've marked them myself. And those refer to the numbers you can see across here on the terminals. Okay, so we know what came from where. The fact that some of them are already marked suggests this has been off before for some reason. Okay. We have a few more things to unplug, but I can get to this. And the problem seems to be a connection in this area. Good question now is, can I actually undo these nuts to get the thing off? And here it is. So I've disconnected all the various plugs and yeah, interesting because one wire here is actually soldered to this plug. It goes into another pin. Which seems strange, so they've gone through all the effort to fit all these connectors and just tag this one on. It doesn't make a great deal of sense. Someone's obviously been here before. Look, the wire is a repair. There's a black mark there where this wire solders. So I'm not the first one to try to repair this thing. Possibly this is just all from a previous repair that was completed. Okay, so this is the board. Let's see if we can figure out what's wrong with it. So here is the board. We can see we have two relays on here. Okay, a number of connectors. 2 and 3 with a fan. One was one end of the transformer. I think primary. 11 was the other end. Okay, but now I have the windings disconnected on the transformer. We can actually check all that out. Okay. We have 2 large power resistors here, and then we have 2 more here, which look like, oh, these are capacitors. Okay, so this is a repair. So these are capacitors, both wired in parallel, I think. Looks that way. Yeah, we can see those 2 ends should connect to each other. Okay, so two capacitors, two large power resistors, which then go to they're in parallel again, here and here. Okay, this goes to this one. So if we just check on the cables going to the transformer, I can just sort of draw this roughly. We can figure out what connects where. We might be able to figure out what's going on with this. Okay, so I had a look at this now. It's a little bit complicated. There's no schematics that I can find. I actually found one post from about 5 years ago, somebody saying they had a schematic but wanted a PCB layout, but that forum post didn't link to the schematic, and I haven't found any other reference for this. But I think I've pretty much sorted this out. And it's a bit of an unusual thing, but I'll show you what I found. So we have live coming in, pins 1 and 2 connected together, okay. And then what I thought was the fan is actually the thermal fuse or thermal trip on the front of it. And then the other end of the thermal trip from pin 3 here, we can see actually just goes to the relay contacts. It doesn't go anywhere else. So it has to pass current through that relay. Now that's normally open. It's a 24 volt relay, as is the other one. So something needs to close that, okay, for current to pass through. Then we have the two resistors in parallel, which are 82 ohms each. So from the relay contacts, we go to one end of the two resistors. The other end goes down here to pins 4 and 5, which is there. And that relay is actually wired across the resistors. So again, this is 24 volt. This will be to prevent inrush current. They haven't used thermistors, they've used these high wattage resistors, and the idea is that this shorts them out once the initial current flows in, and then they effectively don't dissipate any heat, any wattage, because it's shorted. And that pin 4 goes to what I think is the primary winding of the transformer here, okay, and that comes back on pin 6 and 7. So I think this is the main primary. And then we have two more windings here in series with each other. So 6, 7 winding to 8, 9. That appears to be the center tap between the two, because this is about 2 ohms. This is about 2 ohms. Okay. So that appears to be the center tap. And then 9, 10, 11 all connect together. And that goes to neutral. So we have a current path, basically, if this is closed, via the thermal trip, via the relay, via the resistors, through the 3 windings in series back to neutral. There's two problems with this. One, I can't figure out how that closes. And two, that these resistors, meter is working from here to here, are open circuit. So the resistors have gone. Okay, that's why we're getting no power to the transformer, the primary, which we knew. The on-off switch on the front, although it looks like a big main switch, has some thin wires on it going into something. And something has got to generate the 24 volts here. Now, I would have thought these effectively act as like an auto transformer. So that's a bit like this could generate 24 and 24, but not isolated from the mains. And if it was just powering some sort of circuitry, fair enough. There's also another secondary I found on the transformer, which is isolated, which is probably a low voltage supply, and that could also power that. But I can't figure out how it ever gets going, yeah? What I do know, though, is these resistors are gone. So we need to change those resistors and then see if this thing actually functions. I still just don't quite get it, okay? I have asked the guy who brought it in, has he ever seen this working? If so, has somebody been messing with it after it was last working? But I think this is probably all correct, actually. So we'll leave that mystery aside. We need to replace those resistors. The other problem is whatever's shorting the plus and minus supply, the secondary. So we have here a bridge rectifier, so this is ground. This is where your bridge rectifier is, AC, AC, and then we have minus plus. Okay, that's what's coming out of there where the centers are, and that's where the short is. It makes sense I don't see a short to ground because there's no ground actually connected between the output devices of the amplifier. That's where your speaker would go. So if the speaker was connected and there isn't a relay to go to protect, then it would be, and you would see a short to ground. So the fact I don't see a short to ground from either of these makes sense to me. I'm not sure if I have these resistors. Let me have a look to see what I have. And these are clearly not the original ones. These have been changed before. So the value isn't marked on the board. I'm kind of assuming these are correct. Okay. 82 ohms each. Another strange thing with this is this yellow wire. So this is being soldered from here to here, like an afterthought. Seems like it's been there quite a while, if you can say such a thing. But I don't really know why that is there. I mean, it's not to repair a track. I mean, this went to here and that goes over there. Regards how the relay switches on to power this thing up. It looks like we have a connection. In fact, we do from here to here. So this is the live, and then the neutral, which is on here, also goes to there. So this connector has a direct connection to the live, and the neutral, that could be for the fan because it is 240 volt, but it may also power something else somewhere which actually does the relay switching, but then that would have to have a little transformer or something on there. Okay, so what I think we are best to do here is to see if we can get this repaired, or at least to a point where we can test the amplifier. I'll check to see which of the channels has a short on. If only one channel has a short on, then I can disconnect the power to that channel and try powering the amplifier up with this board fitted with the other channel and see if that one works. At least this will prove whether it does power up with this board fitted with the resistors. Even if I have to disconnect both of the channels, I can see if I have the high voltage DC and the capacitors. Okay, so I don't have any of these resistors. I'll order some, so 82 ohm. These are in parallel, so they are open circuit, and that will give you a total, if they were good, of 41 ohms. Okay, so I don't have any of those. I thought of a few combinations. What I do have is these. So these are 20 ohm and 20 ohm 5 watt. So if I put two of these in series rather than parallel, that will give me 40 ohms. Yeah, so very close to the 41 ohms. And that will give me, in fact, I'm looking now, I think that says 15 wattage. So that gives me like 30 watt. So that should be more than enough. But I only really need to fit these just to test anyway. And these are ones I often use as a load on power supplies and such like when I'm repairing things. So I will get some of the proper ones, but for now, let's just connect these up. So it's not particularly tidy, but this is just temporary while I just test this board. And there's plenty of room in the amplifier anyway. Yeah, you can see where they soldered across. So I'll just check that. Yeah, and it reads 41 ohms. Okay. Tolerance was in our favour a little bit. So let's put this back in, and now let's see if we can figure out where the short is, and then we'll test as much as we can with the amplifier. I've put all that into the amplifier. Of course, when I first did it, I forgot to solder the black wire on, and that's take it back out again. Yeah. So what I've done is now I've actually tagged a bit of grey wire to the PCB, and I can solder the black wire here. I'll probably leave that on, actually, just put some insulation tape or heat shrink over it. It makes it easier, that's all. Then you don't have to worry about forgetting. Not that I hope I have to take this thing apart again. I've connected up all the power rails. So we now have this short circuit, and the short is between the positive and negative. Okay, I think red wire, this is actually the positive, negative, short. So we have red wire going to the amplifier here. This one has a green, looks like an earth wire actually. That one, I don't think it is, has a black. So one of the amplifier channels is short somewhere. I can see a black wire down here. So they will come from here. From what I can see, there's a black wire coming onto here. That goes to the bridge rectifier, then there's two green. So one will go to this amplifier and one will go to that one. And then on here, again, we have one coming up from the bridge rectifier and two reds. One to here, one to there. So if I disconnect one of the negatives from here, that's disconnected that amplifier. Do we still have a short? No, we don't have a short anymore. So the short is on this one. So if I connect this back on and we disconnect the positive to the same amplifier, the same thing will happen, yeah? Yep, no short capacitor charging. So the short's definitely on this one. So if I now disconnect both power rails to this, we should be able to power this up with just that one. And let's see what it does. So I'll just take those off, put them where they can't actually touch. Okay. Once again, no short, just the bleep as the capacitor starts charging. Right. So I'll power this up with the light bulb in circuit. And let's see if we have any voltage here now. Okay, so it's set to limit. We can see the light bulb over there. Let's see what it does. Oh, we didn't like it. I think that's the relay clicking away. Yeah, you know, I said there was a relay down there. I couldn't hear it before. It may just well be that that light bulb, 60 watts, is not enough power for this thing. So let's get the more powerful one I have. So this has two 72 watt bulbs, 144 watts. Let's see what this does, okay? Same sort of thing, but at a different pace. I'm sure that's the relay rattling I can hear in there. Ah, this time it didn't. And the fan's going. Okay, it's powered up. So it does power up. We can switch this directly to mains. It was obviously, as it was trying to get some charge into the capacitors, I would say, it was doing that rattling thing. This has 46 volts, so there's still charge in the capacitors. And minus 43, so there's plenty of charge in the capacitors. So it does power up with only the one channel connected, okay? So I'll connect an audio source and a speaker to this one. Let's just see if this channel's actually working. So it looks like this is not going to go bang from what I can see. I've connected the speaker now and an audio signal, Northern Soul of course. So let's see what it does if we just power it up without the mains limiter and circuit, okay? And it powers up and this fan spins. Does it work? This is the next question. So let's just get a bit of audio going. Yes, that's an advert playing. Okay, so, yeah. So guys, I wasn't pushing that. I need to, again, sort out some sort of load. I'm going to make one, but it works on the speakers I have. So the question is now is what's short circuit on the other channel? But we've definitely fixed the problem with that PCB. And this one, well, we have a good one to compare with the bad one.